Hello, mathematicians. Here is the first review sheet for Unit 5. Remember that the review sheets are the best thing to study because they look just like the test. So if you feel great on the review sheet, you will feel great on the test. Number 1, circle the correct name or names. Hint, for all of them, you're going to be circling more than one right answer. The first one, it is a quadrilateral because it has 4 sides. It is a parallelogram because the top is parallel to the bottom and the left is parallel to the right. And it is a rectangle. Rectangle, angle, angle. All about the right angles, baby. If it has 4 right angles, it's a rectangle. It's not a square because it does not have all sides the same length. Second one, it is a quadrilateral because it has 4 sides. It is not a parallelogram because all 4 sides are not parallel, or the top's not parallel to the bottom. It is not a rhombus because all the sides are not the same length. But it is a trapezoid. Remember, a trapezoid is a quadrilateral with 1 pair of parallel sides. And in this case, the left and right are parallel. The third one, it is a right triangle because it has a right angle. It is a scalene triangle. Say, silly scalene. Silly scalene. That crazy scalene triangle has 3 sides of different lengths. It's not isosceles. Isosceles has 2 sides that are the same. And it's not acute. Yes, 2 of the angles are acute, but all 3 angles have to be acute for it to be an acute triangle. The last one in that first row, it is not a pentagon. A pentagon has 5 sides. It is a hexagon. A hexagon has an X in it, just like the number 6 has an X in it. It is regular because all the sides and all the angles are the same. And though it's true that all the opposite sides are parallel, it is not a parallelogram because a parallelogram is only for 4-sided shapes. First one in that last row. 1, 2, 3, 4. It's got 5 sides, so it's a pentagon. So it's not a hexagon. Yes, it is irregular. Irregular means the sides and angles are not all the same. And it is not a quadrilateral. Remember, quadrilateral means 4 sides. Let's meet at the quad. How many buildings? Quadricep. How many muscles? Quadruplets. How many babies? 4. Okay. That next one. 1, 2. Yes, it's an octagon because it has 8 sides. It is not a hexagon. A hexagon has 6 sides. It is not regular because the sides are not the same. So if it's not regular, that means it is irregular. The sides and angles are not all exactly the same. Okay, don't be fooled. All I did was rotated it. It is an equilateral triangle because all the sides are equal. It is also an acute triangle because all 3 angles are acute. It is not a right triangle because there is no right angle. And it is not an obtuse triangle because there is no obtuse angle. And that last one, don't be fooled, all I did was rotate it. It is a rhombus. Rhombus. Just say yes to this question. Is everything on a bus the same length? Are all the seats the same length? Are all the windows the same length? Are all the gardeners on it the same length? Yes. So that's just a silly way to remember that a rhombus is all about the same length. So all 4 sides are the same length. Yes, it is a square because the sides are the same length and they're 4 right angles. Yes, it's a quadrilateral. And yes, it's a rectangle because it has 4 right angles. So that one, all 4 of them are circled. 2, 3, and 4, we can just write a quick explanation. What's the difference between a rectangle and a square? For a rectangle, can you say 4 right angles? And a square also has 4 right angles, but it has something else in addition to that. 4 right angles and 4 sides the same length. So a square is more specific. Number 3, the difference between an isosceles triangle and an equilateral triangle. An isosceles triangle, imagine pointing to your eyes, don't poke them. 2 sides are the same length because you have two eyes, isosceles. And an equilateral triangle, all three sides are the same length. And the last one, what's the difference between regular and irregular? Regular means sides and angles are equal, or the same would be a nice way to say it as well. And irregular means sides and angles are not equal. I think I'll say are not all equal. All right, on to page 2. Number 5, we need to use a protractor to measure our angles. Remember to line up the center of your protractor with the vertex, and one of the rays should be shooting straight through 0, and where that other ray points is the measure of the angle. Now there's two sets of numbers, so I highly suggest that you think about what type of angle it is before you even put the protractor up there. I know that it's an acute angle. If it's an acute angle, you better write down a number less than 90. There is no reason you should write down the wrong number. It's an acute angle, so it's going to be less than 90. On my protractor, I think it's about 70 degrees. I always give kids some wiggle room. So if a kid were to write 65 or a kid were to write 75, I would totally accept it. A little wiggle room below and a little wiggle room above. Okay? That next measure, or the next angle, is definitely an obtuse angle. So I better write down something more than 90. So I think it looks like it's between 160 and 170. So I'm going to write down 165. Again, I would give kids a little wiggle room. If they wrote something a little bit less or a little bit more, I would accept it. Number 6, draw an angle that measures 30 degrees. 30, think, it's going to look acute. So if you move your protractor away and your angle looks obtuse, you probably put a little mark by the wrong number. All right, so the first thing you should do is draw a line segment or a ray, and then go ahead and line up your protractor and make sure that ray or that line segment that you drew is shooting straight through 0. And start counting at 0. 0, 10, 20, 30. Put a little mark by 30. Move your protractor aside and connect your vertex to that little line that you made. And I would put an arc in the 30-degree part. So that way people look at the correct part of the angle. You want them to look at the 30-degree part, not the 330-degree part. 125 degrees is obtuse, so make sure that it looks obtuse when you move your protractor away at the end. Go ahead and draw a ray, and it doesn't matter which direction it's pointing. So if yours is pointing in the opposite direction as mine, that's totally fine. So start by drawing a line segment or a ray. Line up your protractor. Make sure that ray or that line segment is shooting straight through 0. Start counting at 0. 0, 10, 20, 30, 40, 50. Gosh, I can't even see it. 25, 125. Okay. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 125. So it needs to be between 120 and 130. Move it away. Connect your vertex with that little hash mark that you just made and put an arc in there so people look at the obtuse part of the angle like you want them to. Okay? Number 7 and number 8. You probably would take a glance at it and think you need your protractor for it, but you don't. We're just going to use subtraction to figure out our answers. Number 7, Rachel sketched a straight angle. A straight angle is 180 degrees. She divided it into two smaller angles. One side is 70, so what's the other side? Yes, you could measure it, but the most accurate way of figuring it out would be to just do a subtraction problem. I know that the whole straight line is 180. Take away what we know, and that will give us what's left. So if one side is 70, then the other side has to be 110, because 70 plus 110 is 180. So we don't even need our protractor for it. We'll be more accurate by just doing a subtraction problem. Now, could you use your protractor to see if it is right about there? Yeah. But I'm expecting you to use subtraction to figure it out. Number 8, Jason sketched a right angle. So in this case, I'm thinking 90 because a right angle is 90. And then he divided it into two small angles. If one part is 50, what does the other part have to be? Well, the whole thing is 90 minus what we know, and that will give us what's left. So if one side is 50, the other side must be 40 because 50 plus 40 is 90. On to page 3. Ryan has sorted a collection of shapes and labeled them. Take a good look at his work and answer the questions below. So we have a Venn diagram. On one side, we have shapes where all the sides are the same length. On the other side, we have shapes where they're all right angles. So in the middle would be shapes where all the sides are the same length and all the angles are right angles. Letter A says, draw these polygons in the correct spot in the Venn diagram. So I see a octagon, and it's a regular octagon where all the sides are the same length. So I'm going to go ahead and draw my octagon in there, and it's okay if your octagon's not perfect. I'll be able to tell. And the square has all the sides the same length, which is here, and all right angles, which means the square belongs in the middle. Okay? All right, letter B, follow these instructions. Find the regular polygons and color them green. Find the irregular polygons and color them red. Find the quadrilaterals and circle them with purple. Okay, the first thing I'm going to do is grab green, and I'm going to find all the regular polygons and color them with green. Remember, regular means sides and angles are the same. So this is regular because all the sides and all the angles are the same. This is regular. All the sides and all the angles are the same. This is regular. All the sides and all the angles are the same. This one is not right here. Let me draw a little arrow. Not because the angles are not the same. This one is not regular because the sides are not the same. And this one's not regular because the sides are not the same. So the ones that are colored green, totally correct. Find the irregular polygons and color them red. So irregular would be the rest of them. And I think so my picture doesn't look confusing. I'm going to make this black. Make that black. There we go. Okay. Whoops. That change it? Oh, that's the inside. There you go, you square. That needs to be back to green. Okay, so the regular ones are colored with green. The irregular ones are colored with red. And finally, the quadrilaterals. Quad meaning four. Let's meet at the quad. How many buildings? Quadricep. How many muscles? Quadruplets. How many babies? So anything with four sides, I'm going to circle with purple. Okay? All right, and number 10, put one shape in each of the three sections. So I see on one side, three sides, so obviously triangles. On the other side, at least one obtuse angle. So obviously, what's going to go in the middle? It's got to have three sides and an obtuse angle. So what's going to go in the middle? An obtuse triangle. So go ahead and draw that in with an obtuse angle, and then connect the sides. And then just draw another type of triangle. And at least one obtuse angle, maybe a trapezoid, right? A trapezoid has obtuse angles, and maybe I'll even show. Here's obtuse, there's obtuse, and there's obtuse. Remember that at least one obtuse angle means it can have one obtuse angle or two obtuse angles, or you could draw an octagon, which would have 8 obtuse angles. All right, last page, all about area and perimeter. 11 and 12. What is the formula for finding the area of any rectangle? The formula would just be like, how do you find it, right? How do you find it on any rectangle? So area would be length times width. And a lot of mathematicians will use an L for length and a W for width. Number 12, what's the formula for finding the perimeter of any rectangle? I would accept a couple of things. Maybe this is the easiest. Side plus side plus side plus side. You could also do 2 times the length and 2 times the width. So maybe I'll write that down as well. That you could do 2 times the length, right, the long side, and add that to 2 times the width. Which maybe is more sophisticated, a more sophisticated way of writing it, but I would also accept side plus side plus side plus side. Okay? Number 13, what's the area and perimeter of the rectangle? So they're 2 different measurements. Most likely we'll get 2 different numbers. And of course the label is going to be different because they're 2 different measurements. So for area, I need to do 42 times 7. If you know traditional, you could totally do 42 times 7. Which is 294. If you don't know traditional, maybe the break apart method might be the best. So I would split 42 up into 40 and 2. So instead of 42 times 7, do 40 times 7 and 2 times 7. And then put it back together. And again, you get 294. So the area is 294. When I say area, you say square area, area, area. So what kind of feet? Square feet. And perimeter would be adding the lengths of all the sides. So 42 plus 7, don't forget, plus 42 plus 7. Don't just add 2 of the sides. Be sure to add all 4 sides together. And there's a couple of ways to do it. You could do 42 plus 7. And 42 plus 7 and add it together. You could do 42 plus 42 and 7 plus 7. So it doesn't matter how you add all 4 sides as long as you do add all 4 sides. I think I'll do 42 plus 42 to get 84. And I know 7 plus 7 is 14. So I got 98. Say plain perimeter. So just plain feet, because you're just adding the lengths of the sides together. And finally, number 14, same thing. We're going to find the area and the perimeter. Area, I need to do 27 times 9. And if you know traditional, you can do traditional, of course. If you don't know traditional, maybe the break apart might be the best. So instead of 27 times 9, I would do 20 times 9. And 7 times 9. And then add them together. And either way, you should get 243. When I say area, you say square area, area, area. So 243 square feet. That measurement is how much space or surface is on the inside. And the last one, perimeter. You need to add all the sides. 27 plus 9 plus 27 plus 9. And it doesn't matter how you add them as long as you add all 4 of them. I'm going to do 27 plus 27, the 2 long sides. And I know the 2 short sides, 9 plus 9 is 8. Say plain perimeter. So just plain. Oh, I wrote feet. Silly Mrs. Judson. the word they used was centimeters. So I need square centimeters, and I need plane centimeters. There we go. Let me make sure I didn't make a mistake on the first one. Yep, square feet and plane feet. Square centimeters and plane centimeters. All right, here are the answers for page 1, page 2, page 3, page 4. All right, kids, study up, and I will see you in class.